All right, we're on lesson 19 now, which is on page 67. And multiplication, back when you were just doing arithmetic, you just use an X to indicate multiplication. Well, we don't typically do that in algebra because X is a variable instead of the symbol for times. So we can use a dot, which tells us to multiply. So the first example, 19.1, 4/9 times 5/7. And we did multiplication of fractions in one of the last lessons, so we just multiply straight across. So 4 times 5 is 20, over 9 times 7 is 63. And that doesn't reduce, so that's the answer. So the only difference in this is that instead of using an X for multiplication, we use a dot. In the second example, it's written like this: 2/3 raised to the third power. Now remember what that means is that's 2/3 times 2/3 times 2/3. So when we multiply this, it's 2 times 2 is 4 times 2 is 8. And down here, 3 times 3 is 9 times 3 is 27. So it's 8 over 27. And let's see. Let's see what they're trying to show you out of that. Okay. All right, so the next one is on page 68, and it's 19.3, and it's 4/9 times 18 over 30. Now, we can reduce a lot before we do anything else to this. So we can always reduce fractions up and down. So if there was something that went into 4 and into 9, we could reduce it. Into 18 and into 30, we can reduce it. But we can also cross cancel. So we look at those numbers, those two, and we look at these two. And we determine whether there's anything that we can divide out of both of those numbers. So sure enough, out of 9 and 18, 9 goes into itself once and into 18 twice. Okay, then look at the 4 and the 30. The 4 and 30 are both even numbers, so they're both divisible by 2. So 4 divided by 2 is 2, and 30 divided by 2 is 15. So now there's no longer anything that will cancel, so we multiply what's left. So that's 2 times 2, which is 4, over 1 times 15 is 15. And there's nothing else that will reduce for 4/15, so it's in simplest terms. All right, now then, the last one is a division problem. So to divide fractions, remember the first fraction stays the same. The symbol changes to times, and we flip this guy's upside down. We write the reciprocal, which is 4 over 27. And now we do everything we did to the last one. So let's see, we look here and here. Both of those are divisible by 2, so divide each one of them by 2. Now here we can go up and down because 3 goes into 21 7 times, doesn't it? Okay, so now do we have anything left? 2 won't reduce with 27. 7 won't reduce with 27. So we multiply the 7 and the 2 and get 14. And then we multiply the 1 times the 27, so it's just 27. So we're left with 14 over 27. So remember, for division of fractions, there really isn't any division of fractions. You change the division symbol to a times symbol, and you invert the fraction that you're dividing by. In other words, you write the reciprocal of it. Okay, so let's move on to lesson 20. Lesson 20 is multiples and least common multiples. So it says the number 8 is a multiple of which numbers? So that's asking us to say, well, which numbers multiply to give you 20? Is it 20? No, just 8, sorry. So which numbers multiply to be 8? Well, 1 times 8 is 8. What other numbers multiply to give you 8? It would be 2 times 4, and that's it. So 8 is a multiple of all 4 of these numbers. Okay? Now, these are all factors, right? Any numbers that multiply to give you a number are called factors. So the next example is different than this. It says, find all the multiples of 9 that are less than 50. Well, multiples of 9 are numbers that you get by multiplying 9 times any number. So the first multiple would be 9 times 1, which is 9. And it says all of them that are less than 50. So then we have 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. And what did it say? Less than 50. 9 times 5 is 45. 9 times 6 is 54. Oh, and it said less than 54, so we leave that one out. So the multiples of 9 that are less than 50 are 9, 18, 27, 36, and 45. So you get the multiples by taking the number they give you and start multiplying by 1, by 2, by 3, by 4, by 5, until you accomplish everything that they've asked you to find. All right, so turn to page 72. Now we're going to be finding the least common multiple, the LCM, which is a fancy way of saying the least common denominator. All right, so it says find the LCM for 24, 55, and 80. So what we need to do is write the prime factorization for each one of these. So for this one, 2 goes in here 12, 2 goes in there 6, 2 goes in there 3. So that's 2 times 2 times 2 times 3. 55 is just 5 times 11. 80. 2 goes in there 40 times. 2 goes in there 20 times. 2 goes in there 10 times. And 2 goes in there 5. So that's 2 times 2 times 2 times 2 times 5. Okay, so we have to have each one of the different numbers. So we have to have a 2, we have to have a 3, we have to have a 5, and we have to have an 11. That's every one of the different factors. And even though it says this is the least common multiple, you have to list the largest number of times that any number appears. So 2 was here 1, 2, 3 times. Here it's 1, 2, 3, 4. So we have to use the 4. So it's 2 to the 4th times. What about the 3? I only see it right here, so that would be 3 to the 1, so we leave it alone. What about the 5? It's here once. It's here once. We don't list it twice. We only list it once because with the least common multiple, we don't need that extra factor. Just because 5 is in this number and 5 is in this number doesn't mean we list it twice. It's just 5. And then the same thing happens with 11. Okay, it's only in one of the numbers once, so just list it once. So to multiply that out, 2 to the 4th is 16. I don't know if it'll let me lift this up or not. I don't know, it won't. Okay, so we're going to have 2 to the 4th, is 16. 2 times 2 is 4 times 2 is 8 times 2, yeah. So 16 times 3 is 48. And 5 times 11 is 55. So if we multiply that, hmm, 2,640, is that what you get when you multiply it out? Let's see if that's what they got, yes. Okay, so really, the only thing that's different is figuring out what the actual LCM is. We've done prime factorizations. You should be pretty comfortable with that by now. So let's try another one of these. It says, below we show 3 numbers expressed as products of primes. So they're giving them to us already. 2 times 2 times 3 times 7 times 7, that's one number. 2 times 2 times 2 times 2 times 5 times 7, that's another number. And then the third number is 2 times 5 times 5 times 5. 1, 2, 3, 4, 1, 2, 3, 4. Okay, so number 1, or letter A, says what are the numbers? So this is 2 times 2 is 4. 4 times 3 is 12. That's a times in there. And so 12 times 7 times 7 is 49. Okay, so the top number here is 5588. This next one, 2 times 2 times 2 is 16 times 35, so okay, so that one is 560. And then the last one, so 5 times 5 is 25 times 5 is 125. And then that times 5 is 125, so 525, 2. Oh, let's see, 125 times 10. That's what we need to do because we got to multiply by this and the extra 5. So it's the same as 125 times 10, which is just 125 with a 0 on the end of it. Then letter B, we're supposed to find the LCM. So all the different numbers in here. So there's a 2, there's a 3, there's a 5, and a 7. Did I get all the different numbers? Okay, so now we go back and we have to look. We have to take the largest number of times that any number is mentioned here. So this is 2 squared. That's 2 to the 4th, and that doesn't have a 2. Oh, it does have 1, 2. So what's the biggest one? Well, 2 to the 4th, so we're going to use the 4. Then we move to the 3. Well, I only see the 3 there once, so we're good. Leave it alone. The 5. There's 1 in this number. There are 4 in this number, right? So, oh, that's 5, sorry. Yeah, 3 and 5. So there's 1, 2, 3, 4 5s. We have to use the biggest number. And then for the 7s, there's 2 of them up here. So we have to list it twice. It's going to be a huge number. Ugh. Because this is 16 times 3, that's 48. And 5 to the 4th is 625. So times 49, and then, oh, we did that already. So 625 times 49 plus the 48. Let me see, 625 times 49. We're going to have to remember to add 48. Okay, so 9 times 5 is 45, 18, 4 is 22, 54 and 2 is 56. 4 times 5 is 20, 8 and 2 is 10, 24, 25. So that's going to be 5, 2, 6, 10, 3. Okay, so I'd like to say they're not going to give you any numbers like that, but I know how they are. Okay, so I'm going to end this video so it's not huge, and then I'll do the next lesson.